All right, welcome everybody to the Sumo Logic brown bag session for today. If you're not familiar with the brown bag series, we have these types of sessions on the second, third, and fourth Tuesday of every month, cycling through topics from logging, security, and observability, respectively, with a variety of guest speakers and subject matter experts from here at Sumo Logic. So my name's Kevin. I'm on the instructional design team, and I'll be your host and moderator today. Our speaker will be Angad, one of the principal product managers here at Sumo Logic. So as he presents, we will have some time during the presentation for questions, both during and after. But if you want to log in to the chat window here in the Zoom webinar, and you can post your chat messages there, and we'll address them during the course of the session today. So with that in mind, let's go ahead and turn things over to Angad, and he can start his presentation.
Thanks, Kevin. Just give me 1 second. I'm going to start sharing my screen. All right. Kevin, maybe you can confirm you can see my screen.
Yes.
Wait, I'm going to put it in full screen mode. Right. Okay. Cool. Now I think we can get started. As Kevin mentioned, guys, we're going to talk about alert response. This is sort of one of the features within alerting that Sumo Logic launched about 2 years ago. So we just want to give you, in case you are not familiar with the feature, just wanted to give you a sense of like what the feature is and what it does. So very quickly, what we'll cover today is 3 things. First, we'll talk about, the pain points associated with troubleshooting production issues, right? So when you get an alert, here we are dramatizing it as a 3 a.m. story, but imagine you just getting an alert and you're trying to figure out what that issue is. We'll talk about the pain points in that process. Then we'll look at alert response capability and how it sort of can help you address some of those pain points. And finally, we'll do a quick demo of the feature and wrap the session up with some Q&A, essentially. Okay, so let's begin. So this 3 a.m. sort of outage scenario, you get a page that something is going wrong in a particular service or a particular application is not new, right? Everybody, at least every developer might have DevOps or a SRE persona might have sort of had that experience. And there are 3 main steps there, right? In that sort of entire chain of events that unfolds from an alert. So you start with an alert, you get notified that some issue is going on. From there, you have to diagnose and identify components that are sort of are to blame. What could be potentially causing this sort of an issue? Is it even a valid issue or not? And if it's a valid issue, what could be sort of causing it? And then sort of like going through reviewing information gathered, trying to assess, okay, like this is the actual sort of area where the problem originated. Like this is the root cause where that led to all of this happen, and sort of try and patch it up, right? So that's the overall process, like of troubleshooting an issue. And the first part we have a good solution for with the tools that we have today, which is you set up some sort of an alert or monitors that tell you that there is an issue. And you can start investigating. But like taking any step from there of, okay, how do I take that alert and correspond it with my application? Where should I look at? What should I do? Like in the diagnose step, and how do I get to the actual root cause? They are unassisted processes. So if you are very familiar with the system, you develop tribal knowledge, you are a senior engineer, it might be very easy for you to do. But especially for people joining new on the teams and people who are looking at this sort of infrastructure for the first time, don't have experience troubleshooting these types of issues, they might struggle a lot, right? And let's dive a little bit deeper into these unassisted steps. So first one is this diagnose step, right? Here, I think the top of mind question is you've gotten an alert and you're trying to figure out, okay, what should I look at? Like what information I should consume that would tell me what's going on, what's the issue. So the top of mind things for a developer at this stage are, what are all the other things that are happening in the system around the time that this alert fired? And where should I even go and look for to get relevant information? Maybe my admin sets up dashboards in a particular location, or they were shared in some wiki portal or something. How do I access the information that can help me get started? And the biggest pain points here are, people who create the dashboards are not the people who consume it. So your admin might have set these things up, and like you might not have this muscle memory of knowing exactly where to go and find that information, because you're new and you've not done this enough times. The second is, on-call need to also be trained on a bunch of tools and processes within the organization to troubleshoot things. Like a lot of organizations use more than a single tool to go troubleshoot issues. So you need to know what tool to use, for which purpose, and sort of navigate all of that when actually there's a fire, there's a troubleshooting issue that you need to, an issue at hand that you need to address. And finally, I think like the last pain point is there's just so much information there, like with all these dashboards, with all of the queries that you can do, and you have to find the right sort of information that takes you to the root cause. And sometimes it's hard to sort of miss that information in sort of the mountain of like all the information that is thrown at you at that stage. So that becomes like a big issue in this diagnose stage. The next is, I think, the troubleshooting stage. And this is where you like high level know what systems are impacted, but now you want to drill down to a specific component that might be actually responsible for this whole problem. And here, the top of mind things for the person troubleshooting the issue is, what are the observed symptoms and are they relevant to the root cause? You might have 5 or 6 different hypotheses of things that look weird. Maybe only one of them actually is responsible for the end issue. So you have to sort of quickly go through them, comb through them, and figure out which one actually is relevant. So you have to quickly analyze observed symptoms and find if it is sort of like the right sort of issue that you're tracking. And then I think another top of mind thing that people has is relating to past experiences. Has that happened in the past? What we did, what did we observe during that time? What information we got that we could leverage in troubleshooting this sort of issue? And these are also somewhat of like the big pain points that institution and tribal knowledge takes a long time to build. Like knowing that this thing happens in the past and these are the learnings that I can apply is not easy. If you're a seasoned professional on the team, if you're a seasoned engineer on the team, maybe it's easier for you, but especially for junior engineers, that might not be that easy. And then like quickly doing querying and running queries to figure out whether the observed symptoms are relevant to the root cause is not easy. Like that's an art, and it does not come that it's easy. I was on call on Sumo Logic's team, and I can tell you that like my level of proficiency of querying and finding some of these issues compared to my other teammates was very different. So there's definitely sort of like this art and science, which puts certain individuals at a disadvantage. So how do we fix this, right? This is what we were like doing when we wanted to design alert response. These are all the sort of problems that we wanted to address. And like, hopefully we are doing that with our alert response capability, right? So in a nutshell, what it does is it it's a capability that provides out of the box experience to help guide, on calls to troubleshoot issues quickly. And it does that by doing by surfacing relevant information that connects the alert to the underlying issue. Like you're basically trying to sort of connect that main sort of alert and giving you as much information that we can possibly do automatically to help you get started, like reducing the barrier for that initial alert dilemma of, oh, I got an alert, what do I do next, right? Like, where should I go first? And then the second thing it sort of does is this guiding the root cause analysis by automatically identifying abnormalities in the system using our AI and ML analytics. So I'll get into that a little bit more, but essentially the system will analyze automatically your logs and your metrics and say, okay, I saw these interesting patterns in the data that you're sending us automatically, and they might be related to your alert. So rather than you having to, run queries to uncover these patterns, etc., like system is already surfacing it out for you. All you have to do is look at the patterns from a human perspective, validate whether those sort of actually are causing issues or not, and then sort of like take corrective actions from there. Right. And all of this happens out of the box when you set up alerts within Sumo Logic, and there's no additional setup that is required from you as a user, right? So with that being said, let's dive a little bit deeper to understand like how alert response sort of works, right? So it all starts with, we provide this sort of a landing page experience. We call it the alert page. When an alert gets triggered within Sumo, on calls are directed to this alert page from a notification. So you can have a notification in email or Slack. You click on a link, you can get to this page. There's also a alerts list page that allows you to get to this page directly, like within Sumo itself. So if you don't want to open it from a notification, if you are already in Sumo, you can go to the alerts list page and find the alerts that are firing right now and open them up from there. Once you're on this page, we provide you some basic information about the alert. The first section tells you what query, basic information about the alert, the query that triggered the alert, some sort of visual indication of the KPI that was behaving incorrectly that fired this alert in the first place, other information, how long it has been active, when it has been active, etc. Then we also give you information about other alerts that are happening in the system that might be related to this alert, right? And this relationship happens both at a temporal level, so they are related to this alert in time, so they happened around the same time, and relationship by entities, so they're happening on, let's say, the same node or the same pod, etc. So we sort of like identify relationships based on both those dimensions. Other thing it sort of tells you is historically how this alert has fired in the past. Like, is this a alert that happens every day, multiple times during the day? Maybe it's a flaky alert, or it only happens very infrequently and sort of tells you that, okay, whenever this alert fires, there's actually an issue going on or something. So you can actually get that alert history as well. And finally, we also show you a playbook. You can add a playbook to an alert. This, like admin, when they are creating a monitor, they can add playbooks that will be shown as part of the alerts. So this can contain any tribal knowledge that the admin or the alert author thinks is important for the person to troubleshoot the issue. You can talk about, looking at specific dashboards. It can talk about sort of instructions on, restarting certain sort of machines, etc. It could be anything there. So sort of this is the alert detail, and then we'll get into, we also provide contextual information. We have context cards that provide additional information about the alert. I see a question on the chat, so I'm going to address it right now. How do you access the monitor nodes? That is a great question. I'll actually show you it in the demo. But very quickly, there is a book icon at the top here on the alert. When you click on that book icon, the playbook section expands in the same place where you see related alerts, etc. Right. Okay, so I'll continue for now. So then, like I mentioned, we have these context cards. Apart from this sort of like basic alert information, the context card basically are system curated insights that might help an on-call get to the root cause easily. This is, you know, you can think of this as anything that the system automatically found interesting that we think you should look at that might help you troubleshoot these issues. So basically some sort of you can think of a guided buddy or a assistant that helping you like with the troubleshooting of this alert. And there are different types of these cards that are available here, and they solve different purposes. So I'll get into the details of those cards. The first card is called, we call it a log fluctuations card. And what this card does is identifies changes in log patterns and signatures that might help explain the underlying issue, right? Patterns, for example, could be error patterns, exception patterns, timeouts, right? So you can see in this example, it has in this card, we have found 4 different interesting patterns, right? All somewhat related to some error or failure. And what this card is telling me is that all of these patterns are net new. That is, these types of log messages only started appearing when the alert fired the first time, right? Before the alert fired, before this alert ever happened, we never saw these types of error patterns. And it also tells you, the bar chart on the right tells you like the magnitude of these error messages. So the first signature, there are around 25,000 log messages with this signature after the alert fire, as opposed to none before the time period before the alert was ever fired. So this tells you, okay, these are the sort of like interesting log messages that I need to look into a little bit more why they are happening. So sort of narrows down your area of focus in terms of what logs you want to look at and why. You can actually click the button on the right here to take you to those specific sort of log messages to analyze them in more detail of what that actual that like failure is in this case. Okay. The next one, a card is called dimensional explanation. Here, the system analyzes log data and surfaces dimension. These are the fields in your log data that might help explain an issue, right? So for example, in this card is telling us that error started happening while taking the cart, while talking to the cart service, and 80% of the logs that have the word error in it, are associated with the underlying issue. So, this key value pair appeared the most. Log message error request and log severity error appeared the most in terms of in the logs that are related to the issue. It also tells us sort of other sort of messages that, or other fields that appear more disproportionately in the error related activity, right? So in this case, could not retrieve the error message could not retrieve from card was in around like 80% of the log messages that correspond with this error. This we found interesting. So maybe there is something related to cart that I need to look at more in order to troubleshoot this issue in this example. Okay. The third is called the anomaly card. It finds anomalies in the metrics data that is sent to Sumo Logic over time. And it also tries to find anomalies in like the metric value and how these entities relate back to an alert, right? So in this example, it is showing pod failures in a bunch of different services, which might be related to the alert, right? So pod failing, etc., obviously is an anomalous trend, and it will capture it. And this happened around the same time as the alert. So they are sort of points of interest, and we surface those out. Finally, we have the benchmark card. Here we compute abnormalities in metric data again. But in this case, we compare your anomalies to other customers. Like we normalize data from all the customers that Sumo has and say, okay, you are experiencing certain types of things far more often than other Sumo customers, right? So not just looking at your past data to make inference about the anomalies, but across a cohort of customers. In this example, you can see that service unavailable error is happening 32 times more often than for other Sumo customers, right? So maybe you need to look into that in terms of like why this service is sort of unavailable more than what other customers are experiencing. Cool. Okay, so with this sort of, hopefully you can see that the way sort of alert response solves this problem of like monitoring, diagnose, and troubleshooting sort of steps that I showed earlier is, guiding you in sort of like step 2 and step 3. It will not sort of solve those problems automatically, but sort of be a buddy or like an assistant for you to help in sort of like in that process. And with that, I will jump over into the demo of the product. Okay. So you typically start off, like I said, like you get an alert. In this case, we have a Slack message configured, right? Where, I have a sort of a coffee application where people can go. This is a demo application where people can go and sort of, buy coffee online, and sort of the service helps you sort of with the process of buying and purchasing coffee. So think of this as sort of like an application in a coffee house or something. So in this case, we are getting the alert is the coffee prep time has increased, which sort of there's a huge delay in like creating those in actually serving the coffee request for customers. And this is the alert that got triggered, right? So like I was mentioning earlier, it has some basic information. This alert was created from log messages. In this case, I have a log message that actually has the prep time information about the coffee, the latency information, and I'm just basing an alert on top of it. You can see, yes, at 5 a.m. in the morning, the prep time suddenly went from like 3 milliseconds to actually 3 seconds, and it stayed there for about like in half an hour there, and sort of like then somebody actually troubleshooted that issue, and it came back to normal. Other interesting information, like I was saying, it also tells me all these related alerts. There were a lot of related alerts that were firing in the system around the same time as this alert. And you can also see alert relationship in, like I was mentioning, entities. So the same entity, did it had other alerts? No, in this case, the same entity did not have other alerts. And time-based, in that 30-minute range, what other alerts in the system were firing? Maybe they are sort of like impactful for you. Maybe you want to look into one of these alerts, and you can click on this, and it will take you to sort of like those alerts if you want to review those alerts, right? And then, like I said, monitor history. It tells you how often this alert fires and when it fires. In this case, this is a demo environment, so this alert fires twice every single day. So there's a consistency pattern here, but in real world, you will not see sort of like this pattern. This information can, history can give you a lot more information about sort of like that alert. We also have the raw log data or metrics data that was used to power this alert. So you can actually see the raw logs. to get some context about the alert itself and what log lines were used to create those alerts, right? And then down below, we have the cards that I was mentioning. So in this case, the system found that my front-end service, then the coffee bar service, had a high abnormality in CPU usage. I can click on it and I can see that abnormality. In this case, the CPU utilization suddenly started spiking around the same time as the error itself. So the latency might be because of the CPU increase on the front end. It also tells me that the coffee machine service, which is the backend service to my front end service, also had a high CPU. So maybe the problem originated there and not the front end. And here also there is a high CPU utilization, right, that I can see. And then log fluctuation is just giving me interesting alerts that are happening. So here it is telling me, or interesting, log messages that happened around the same time as alert. There are threads stuck in, waiting for some file descriptors to files to open. This might be because of the CPU problem, right? So just threads are sort of waiting on this. So gives me some additional context about them, about the issues, right? Before I sort of go into these, I can actually, like I was saying, I can actually open them up, but for now, I'll stay on the alert page and talk about a couple of other things related to the alert. Somebody had asked, where can you access playbooks? So this is the button. You click on that button, you can see the playbooks here at the top. Right? I can even expand it. No, it's not expanding. Some issue there, but I don't know why. Okay, I'm facing some issue. Maybe there's a bug or something here with this. It's not allowing me to expand. Anyways, playbook is something that my alert author had added to this this alert, and you can actually see how it was added. So in this case, I can click on this monitor. This is the monitor that fired this alert. And if I open this monitor up, it can actually show me the playbook associated here. So I've actually sort of added my playbook here in form of a markdown syntax. And you can actually use Terraform, or you can create alerts programmatically through the API or Terraform in Sumo. So you can actually version control and manage your playbooks in an external repository as well, and then sort of like add them to the Sumo Logic monitors. So in this case, this is the playbook. It's asking me to review an SLO dashboard. So I can actually go do that. I click on it. It opens up a SLO dashboard. Tells me my current SLI is sort of at 97%, my target is 99. So I'm actually sort of already under budget. It also sort of shows me my burn rate here, and when the issue happened. Because this is a demo environment, like this issue happens like every couple of hours, like I mentioned. So you will always see like some red bars here. Right. So it gives me some high level insight into, yes, this is going to cause some issues for me. It is going to impact my SLO. So I need to really pay attention to this alert. Okay. Next, in this case, the author of the playbook has sort of shown me or given me a dashboard that I should be reviewing. So rather than identifying all the dashboards from this left nav, I'm sort of like already provided a nice sort of dashboard for this alert. That dashboard gives me high level information. So tops down observability shows me, yes, the latency was high around the same time as alert. Page loads time were also high, and the latency was on seems like on two different services, the front end service and the coffee bar service. Right, very similar to what we had sort of seen in the anomalies card that told me that the backend service was impacted. So let's quickly look into this backend service. So this is our coffee bar service. This is the backend service. Here I see that the latency time period, is it correct? Let's filter down to the time that we want to look at. So in this case, this alert would have started in the morning. So during this time, when latency was really high, I can actually see in the graph, yes, this is the backend service. The latency was high here. The error trend seems okay. And because sort of this was instrumented with our tracing service, also I can see that this coffee bar talks to this coffee cache desk service and this coffee machine service. And I can actually go into those and see like if they are also acting strange or not. So I can do this. For some reason, it's not taking the same time. So let's see. So we're looking at one of the related services, the cache test service. This seems normal, doesn't seem like it had an issue. So I don't need to pay attention to it. The other is this coffee machine service. And if we remember correctly from our alert also, I think that was coffee machine service. Yeah, so coffee machine service. So I see that it like coffee bar is connected to coffee machine, and we already are. So let's investigate that service a little bit more because it was showing up in our anomaly cards as well. So let's open this up. And connect. Okay. Here we can see, yeah, the latency is definitely high on this coffee machine service. So the chain of events seems like in this case happening is we have a front-end service that has a high latency that is talking to coffee bar service, and coffee bar in turn is talking to the coffee machine service, right? And seems like coffee machine service might be the source of that latency because sort of like this is the most upstream item. We knew from the alert that the CPU utilization on that coffee machine service is high. So I can actually now go back into the coffee machine service and look at the specific like the dashboard associated with that. So here is the dashboard. It tells me some basic information. I can go into another view here if I want to. Right. So you can see here that, yes, it sort of like this dashboard is showing me that CPU utilization around the time of this alert, we were hitting the limits. So this is our limit, and our CPU was spiking up and down related to that limit. So maybe we are bottlenecked on like CPU that might be sort of having that cascading impact across the services where everybody is sort of facing latency. So maybe a quick solution would be for me to essentially raise the limits for this service for the time being, and that should help me solve this issue, right? So you can see here, like very easily with the alerts, you can have all the contextual information to actually help you troubleshoot the issue quickly and effectively using this alert response feature. So that's it for the demo. I wanted to share with you, the slide deck will be available to you guys later on as well. So I have some helpful links to help docs, to our micro lessons, and a blog that talks about this functionality a little bit more in case you guys want to get more insights. And with that, I'll open it up for more questions that people might have regarding this topic.
Yeah, we don't have any outstanding questions right now, but if anybody has any holdover questions, go ahead and post it to either the chat or the Zoom question and answer section. We can answer it here. Okay, if not, then I think we may be good here. I'll go ahead and stop the recording. And thanks to everyone for attending. Thanks to Angad for presenting today.
Thank you, everyone.
And
Thank you everyone for attending.